But first, we are going to talk about human factors. Why do we talk about human factors first? Well, I'm going to give credit where credit is due. It's having a conversation with the FAA. One thing you're going to figure out about me is I actually really like the FAA. I think that they're a great bunch of men and women who are, for the most part, deeply concerned about aviation safety. They have a love for aviation safety, and they want to pass it on and make sure that it's being followed correctly. Many years ago, the FAA was more of the cops. They were strictly an enforcement agency. And they openly came out and said, you know what, we realized that us being cops, us catching you doing something and showing up and giving you a violation, pulling your ticket, doing something, a punishment, was not instilling safety. What they figured out is that for the most part, most mistakes are honest mistakes made by honest people, and they never intended to do it. It wasn't an intentional error, it wasn't a flagrant violation. And so they learned or figured out that through education, they could achieve much more. And so the FAA is almost just like another layer of education, if you will. And I've really come to see that in them, where they're very much into promoting education. There's, if you're a pilot, you've heard of the WINGS program. Well, there's something like that for us mechanics. It's the Amt Awards program, and I'm a big fan of it. And what you do is you go to faasafety.gov and you create your own. I should do this because this is really good stuff. Now that I'm thinking about it. faasafety.gov. And you create an account. And you can go to courses, and they have these fantastic courses that are actually really well done. And every year they have what they call a core course, and they're free. And the core course usually take you maybe an hour, maybe a half an hour. And they have all of this. And then what you can do is you can compile your training, and you can get an award. And this would be much better if this website actually moved faster than I can talk. But so every year, let me see. Courses. What's that? I've been busy. Okay, so this is my account, and so every year you can look and see. Oh, I've got 18 hours of continuing education so far. Totally voluntary, but just plug in what you want. You have to do the core course every year. I don't remember what the core course was this year because I actually go back and watch so many of them over and over again because I like them so much. Last year was exhaust. I don't remember what the core course is. Proper torque. That's what it was. So this year it's about proper torque, which is very appropriate for us. So you could actually go watch this because what the FAA finds out, they'll look at something and go, this is the problem area we're having. And I'm looking at it right now going, hey, guess what their problem area they had last year was? That they said, this is where we need to focus our training. Torque, proper torque, which we're going to talk about in this course. Year before that was, I think, exhaust systems. Year before that was following directions, or is actually post run-up maintenance items for aircraft. Very, very good courses. So you create an account, and you enroll, and then when you finish this, you can actually add in other courses. Like I went to non-destructive testing course. You just go in here. It's honor system. I say, hey, I went to the. Actually, you have to upload a certificate, so it's not. So did that. They give you credit for taking college classes in relation to aviation. You guys know anybody taking a college course that is related to aviation right now? I know 40-some people right now. Yeah.
Can you go to previous years or no on the website?
Oh yeah, absolutely. Yeah, I was kind of trying to get there, but let me see. See courses. Courses come up. Now I think there's so many it just takes a while. But I used to give credit for students who did this, but the problem is they were doing it in class and double crediting. So, all right. So failure to follow. Oh, these are the ones I'm enrolled in, I think. Available courses. Available courses. WINGS is for pilots. AMT is us, aviation maintenance technician. Am I there? There we go. Not all are free. The first ones are. So, what that is. Haven't seen that before. No, those look like wings courses. These are all of them. Anyway, we can go through. Failure to follow procedures, human factors for aviation. We're going to talk about that tonight. Maintenance error avoidance. I mean, these are fantastic stuff. You can see they're all free. Then you get down here into the cost ones. Some of them are very expensive. But this is something you should be doing. Although you're in class right now, so it could be a bit much. But anyway, so I'm telling you that to tell you that this is the way the FAA has kind of progressed. And I'm very much appreciative of that. And they have within the FSDO is FSDO, Flight Standards District Office. It's the local FAA office. And of course, FAA stands for Federal.
Forms and Applications Administration.
Mike's. So Federal Aviation Administration, they're the overseers. They're a federal agency who oversee what we do. And they have what's called the FAST team, which stands for something aviation safety team. I forget. But anyway, so it's just a team within a team that's focused strictly on safety. And they do training seminars, and they're a lot of fun to talk to. And so I was talking with one of the FAST team members, and he says, "Hey, let me ask you, Kevin." He goes, "Are you guys teaching human factors?" I said, "Well, absolutely we're teaching human factors. I know for a fact that that's a second year module, and they teach it, and in fact, they just finished that." And he says, "Second year module, huh? Don't you think maybe that ought to be day one stuff?" And I thought about it for half a second. I thought, you know what? He's right. Human factors should be day one stuff. And I'm going to tell you why human factors, because the statistics actually show that, well, actually I'll take a line from, I think it was James Reason, one of my favorite authors on human factors in aviation accidents, said if an evil genius was going to design something, I put it basically to drive people mad and cause accidents, it would be the aircraft. You're talking about something that has constantly critical parts being removed and replaced, done in poorly lit, small areas, uncomfortable positions, and bad temperatures. It's a recipe for a disaster. And so there we have aviation. And the funny thing is, aviation, if you look at the statistics for accidents, it's pretty much kind of level. I mean, it was a lot, and this graph comes down where accidents have sort of stopped. I mean, we brought it to a point, but we can't get it to go down anymore. And the experts are pretty much saying that the reason why is because we have made the machine nearly infallible. The machine is near perfect. What is not perfect is us. And as try as they can, they couldn't really fix us, right? And in fact, what happened is it was, even when I graduated in the school back in the 90s, there was no such thing as human factors. At one point, they had this zero errors policy, which was some companies don't screw up. Okay, well, having a big poster that said don't screw up or don't make a mistake, is that really going to help us at all? So, somewhere in the late 80s, early 90s, this guy by the name of DuPont, he's up in Transport Canada, he starts looking at all of these accident statistics. And he starts putting them in basically 12 piles, saying, so everything that has got something to do where a human messed up, you ended up with 12 piles. It was one of 12 reasons why people screwed up. And so this became known as the Dirty Dozen, which we're going to get into. So just kind of so that didn't happen until like it was late 80s, early 90s. And so it was sometime after that, which to me wasn't that long ago, that the FAA finally came out and said, wait a minute, we got to make human factors part of our training in schools and get posters and start talking about ways that we screw up and things we have to look for. So mostly human factors have been focused on cockpit. They call it CRM, Cockpit Resource Management. And as mechanics, we were just kind of left out of it. And then they realized what a great thing this was to talk about how we work, our brains work, and it's actually, to me, quite fascinating. So Let's see here. Human factors. So I have, you'll find out I have all of my notes, and sometimes I write notes to myself, but then if I don't put them in here, it doesn't make sense to you, so I have to start out. And so what I do is and sometimes these numbers get off, and you just deal with it, all right? And so I'm going to write notes as I talk, and what we're talking about is human factors. And sometimes I don't write so nice. Don't be afraid to, say it nicely. Hey, Kevin, are you really sure you want to spell it that way? Who's my good speller in here? It's usually the person, then you should be sitting right here. And you got to whisper up to me, psst, Dog only has one O in it, dude. So. It's all right. So I want you to know that, and this is one of the things that I probably didn't need to write this, but being an aircraft mechanic is serious business. Being aircraft mechanic is serious business. So, and you all know this. Now, I don't want to say anything negative about car mechanics, because in some ways, car mechanics, they have it worse than us, because if you look at the technology of a car, it is so far beyond where aviation technology is. Our technology, especially on any Cessna, is somewhere around 1965 at best. Maybe a glass cockpit panel is in there, but otherwise it kind of stopped. And the reason why is litigation. It's not like the technology isn't there, but in order to get something into an aircraft, a certified aircraft, it has to go through the certification process, the litigation process, be foolproof, tested. The cost is so expensive. Then you create this thing that costs you $1 million to make, and you sell it to 8 guys. So it just doesn't progress. As where cars, you just, my dad worked for General Motors for Cadillac for a while. And he said, basically, Cadillac, they would just make something and just ship it out. I wonder if that works. We'll find out when the consumers buy it, because what's the worst that's going to happen? Well, I shouldn't say the worst. What is likely the worst that's going to happen? The car breaks down and you recall it, call AAA, or you don't recall it until the lawyers make you do it, like they did with their ignition switch problem, or something like that. But, otherwise it's not that big of a deal unless something blows, Now, the funny thing is, now I say that, as technology is progressing, what are some of the things in cars that are actually killing people because technology? What is that? Airbags. That's what I'm thinking. Airbags, the General Motors ignition switch on the low end stuff. People don't know how to use their autopilots. Right? I'm not blaming the technology yet. My mind is still thinking that's a human error problem. I think the machine probably will. But anyway, so we're starting to see that. But so in aviation, of course, when you make a mistake, very small mistakes can create catastrophic consequences. All right, so we got to know that it's serious business. And I don't want to bum you out on the first day, right? Because we talk about all these rules and stuff. Now here I come. I'm going to start talking about some of the negative sides. But you know what? If everything is pie in the sky, we don't face reality, then that's a bad thing. So we have to look at reality. What is the career field that you're going to get into right now? It's an awesome career field, and I've told you, and you've seen, it's on YouTube, so it's true. I loved my job as being an aircraft mechanic. Absolutely. Sometimes I hated Fridays because it was like, oh man, I got to go home for 2 days. I'm right in the middle of a great project. Can I just stay and I'll come in tomorrow? No, we're closed tomorrow. Go away. So, all right. Only 12% of aviation accidents. 12% are maintenance related. That's a pretty good statistic, right? That tells me 88% are not. Pilot error, weather, some other problem. So 12%. So if there's a crash, and I got to tell you, once you get into aviation and you hear about a crash on the news, you see something on, I don't know who watches the news anymore, but you see it online. As an aircraft mechanic, you instantly go to it. And your first thought is, I hope it's not somebody I know. I hope it's not something I worked on.
Like the helicopter that crashed in New York today.
Today? See, I didn't even aware of that. Okay.
It landed on one of the skyscrapers, an emergency landing.
Everybody okay?
Nope.
See, you hope it's not something you worked on and it's not somebody you know. You're in it long enough, it's going to be somebody you know, and it's going to be something you worked on. Doesn't mean you made a mistake, but let me tell you from experience, it can be a long time before the NTSB and the FAA says you did nothing wrong. That was 100% pilot error, and even if it is 100% pilot error, I will tell you personally from experience that does not mean that you won't get sued for millions of dollars. Yeah.
So say if you worked on something 3 months later, something happens, it crashes, whatever.
Huh?
They're going back to every person who worked on it for how long
For how long? For as long as they want
Really?
to. Okay, well, it depends, and that happens. It happens. I'm going to tell you right now. I was involved in a heavy litigation. I don't know how much I should give out, but I built engines. That was my thing. I did a lot of other things, but what I loved the most is building engines. So I built a lot of aircraft engines, and I did them from start to finish. I did the non-destructive testing. I did the machine work. I did the building, the painting, the whole thing. So there's no other fingers to point. And I had an aircraft crash, and I went to the accident site on the day, and there it was, my engine. And people got hurt pretty bad. Nobody died, but it was close enough, right? And it took a while, but the NTSB, FAA, and everybody said zero fault on my company or me. It was clear-cut pilot error. The pilot turned the fuel off. No matter how good an engine you make, when you turn the fuel off, it's going to stop. Stopped on takeoff, fell straight down, broke everybody's back. Nobody walked again. So, what do the people in the aircraft do?
Well, they don't know any better. They go to blame the engine.
Well, first thing you got to do is you got to go to the people who built the engine and sue them. Then you might as well sue the aircraft manufacturer because they have more money. Go after the engine manufacturer because they got money. While you're at it, how about the propeller and everybody else? So you're just drug into court, and that's just the way it is. So I worked for a company who had a good insurance, and the insurance took care of us, took care of all the litigation stuff. We settled out of court for something like close to $1 million.
Just on your company's side of the lawsuit.
Yep. For zero responsibility. Proven beyond a shadow of a doubt.
Questions why?
Our attorney said, you want to go up there and you want to have a couple guys in wheelchairs come in and 12 people look at that and look at you sitting there, the owner of an aircraft company, they're going to eat you up. There's going to be, so, yeah.
How did they find out the pilot actually didn't show up to
Well, he admitted it. They found it, well, no, because even after the crash, but he admitted it. He was an honest guy, and in fact, we never had any litigation from that pilot, so I want to make that clear. Or the person, it was the backseat guys who just didn't know any better, I don't blame them, you just do what you got to do. But but again, not to bum you out, but I'm saying that this is the industry, right? This can happen, and it's nothing I did, and I'm very thankful for that. But things happen, and you have to have the mindset right off the bat that I'm going to be safe. I'm not going to screw up. And so what I'm kind of telling you here is, if we look at this, number one, there's not a real high probability that the accident is going to be caused by maintenance to begin with. Is that good news?
Yeah.
Okay, I don't have this written down, but I believe it's something like, of all of the accidents, 80% of them are human error. So that's a big problem, right? All right, so we'll keep that in mind. So 12% of aviation are maintenance rates. Only 12%. 88 or something else have nothing to do with this. All right. But keeping with what we're talking about, that means you want to keep good records. You want to have good practices. Because trust me, when that happened, guess where the FAA was first? Work orders, invoices. There's a lot that goes into an engine that doesn't go into a logbook. I have records of every dimension that I took. I have non-destructive testing records of what I did to test components. I have records of that day of what I did to set up my machines. In non-destructive testing we use, this particular one we use Magnaflux or magnetic particle inspection. Did I set it up with a Ketos ring? Did I do my light checks in the morning? Did I do white balance, black light checks? Did I do concentration checks on the bath? Yes, I did, and they're all logged. So it goes way deeper than what you'll see in an aircraft logbook. So investigators come in and you start showing this, that's really good. So you want to be very detail-oriented about everything you do, even if it's not your fault. All right, but bad news. That wasn't bad enough. All right, but of that 12%, 90% are fatal. So what I'm saying is if an airplane goes down, it's only 12% chance that it was maintenance related. But if it was maintenance related, the chances of it being survivable are not good. So most, I could reword this, most aviation accidents are fatal, or most aviation maintenance related accidents are fatal. So don't mess up. All right. All right. Now I don't have this in my notes, but I want to say that I believe this is right. 80% of all accidents are related to human factors. Which is to say, it was something that a human should not have done. It was a problem. Now, I don't think I have this in my notes. Let me see. You can tell I kind of actually like human factors. I think they're fun. Yeah.
Of that 80% is the human error, is that pilot or the mechanic?
Yes, pilot or. All right, so this is not in my notes here. Well, let's make it D because I want to drop out D. All right, so this guy James, and I love that his last name is Reasons. I believe it's Reason, not Reasons. Anybody know Reason or Reasons? Reason, James Reason. So James Reason, he's this guy who comes up with the Swiss cheese theory. Swiss cheese. And what he says is like, you got to think of there's so many things running through my head. Okay, so Swiss cheese is like each he doesn't say it this way, but like it's a procedure. Actually calls it a defense. It's a defense, all right? That's what it is. So each slice of cheese is a defense. And a defense is something that you've set up to protect yourself. Like when I built an engine, I had something to protect myself. I made up a one-page checklist that somebody had to sign whenever I did something important. Question?
This isn't really like about this, it's about like tests. Are we able to use the notes on the test?
No.
at all, or
No. All right, so I built an engine, and when I would finish putting all of the crankshaft, connecting rods on the crankshaft, I would go grab somebody. It's Matt, right? Michael. That's got the right letter. I've been working. It's one letter at a time. I'm one letter at a time. Michael. So Michael, I'd say, Michael, you have to come with me. I need you for a minute. When you're done with your task, I need you in the engine shop. So you would get to a stopping point, and then you would come in. Yes, can I help you? Like, I need you to quality control my engine, and you'd be like, Kevin, man, you never really built an engine. You're the engine guy here. I'm like, I know, but here's what we're going to do. I'm going to show you that I put these connecting rods on right. And okay, this is what I did. Here's my page and my manual. See how the rods have to be like this? And you're like, oh yeah, good. Okay, now they're all lined up on this. You see how this is lined up? And see how these are all torqued and these are all set? And you'd go, okay, and you'd sign it. Now it seems kind of crazy that he signed it off for me. But in my world, what it did is it made me stop. and explain everything I did, and he visualized it and we said, okay, I can do that. And so two of us looked at it, right? So it made sense. So that was like one of my defenses. Okay. And so then you have other defenses that are set up. And, they can be quality control, they can be procedures, they can be, whatever it is. Well, James Reason says you have all these defenses, but all these defenses always have holes in them, like a piece of Swiss cheese. Like, for example, he didn't really know what I was doing. I'd explain it to him. He'd never seen it more. That's a hole in my cheese. All right. I'm using a manual, but maybe my manual was a little outdated, or there was an error written in it from the factory. A little hole in the Swiss cheese. That's my next one. And then, it just keeps going on. Somebody else is going to install the engine and test run it. Maybe they didn't test run it with proper gauges. There's a hole in the Swiss cheese. And so all of these things line up, and there's all these little holes. Well, generally speaking, there's not an accident until all these holes line up. He didn't check something he was supposed to check because I didn't tell him to, because he didn't know. The hole lined up perfectly with, it wasn't written in the manual quite right, so I missed it too. Those holes lined up. It went out for testing, and on the test stand, somebody didn't have the right gauge, or maybe a test club. I showed you guys what a test club is, and they decided, hey, we don't have a test club, we're just going to use the propeller, and we're going to shorten our test run. There's a hole in your Swiss cheese. They put it on the aircraft, and the person putting it on the aircraft didn't run up the engine. They didn't have a lot of time. They did a quick run up, turned it over to the pilot. There's a hole in my Swiss cheese. Pilot gets in it, takes off at night over a populated area, and it throws a connecting rod. Engine fails, goes down and crash. It's because all those holes in the defenses lined up. Any one of those slices have moved, and I wouldn't have had an accident. If he would have caught it, because he was experienced. If the book would have had a better explanation, I wouldn't have missed it. If it would, the person who tested it would have had a test club, it would have failed on the test stand and not in flight. If the person putting it on the aircraft would have done a proper run up and ran it up to full power for an extent and set up the fuel flows like he should have, it would have ran enough that it would have, can you see where I'm going with this? So
They're all human factors as well.
they're all human factors intertwined with this James Reason model. In aviation, I've also heard it called the accident chain. Every accident has a series of events. I don't think there's a single reported incident where there was just, there's just one thing and it happened. Boom, that was it. It's always a series. And that gets into what is called active and latent problems. Active? No. Okay, did I get it right? Active and latent. So a latent problem is something that's laying dormant, like that manual that was poorly written, or a crack in something that's been there for a very long time, but it didn't really matter because it really wasn't stressed enough to cause a failure until this thing next to it failed. You see, that's just something waiting. And then the active is something that just caused it. Maybe a part on an aircraft wasn't designed properly, but it wasn't strong enough, but it never mattered until that pilot got into bad weather and got disoriented and pulled back too hard and overstressed it, and then the wing fell off. You see, latent and active. So active was the pilot, the latent was the problem just sitting there. But there's two things. It's a chain, right? So the idea is to always break the chain, or fill the holes in the Swiss cheese. Use American cheese. I knew there was an answer to this. All right, so let me see. I really got off on something. So, good news is when I go off on something like that, you don't have to worry about, oh my God, what should I be writing down? I'm always going to come back and go, all right, what did I talk about? What should I write down? Well, I wrote the Swiss cheese thing down on there, and that's kind of what I'm going with that. All right.
What's the term you use when you say there's a series of little accidents that cause the major accident?
Chain of events? Chain of events. All right, 3 types of human. Now, it's kind of hard because there's so many different types, but really we're just going to go with a couple things. So 3 types of human error. All right, we have omission. Not performing an act or a task. Not performing an act or task. It could be unintentional or intentional. Let's think. What could be an example of this? So it's something you were supposed to do that you didn't do. Did it on purpose or not? Trying to think of a simple thing. We think, okay, so you're supposed to put a spark plug back in a cylinder. And the maintenance manual says that you should put a new gasket on it, put anti-seize on it, put it in, tighten it, use a torque wrench, and properly torque it. But you're not in a position where you can do that. So you decide that, you know what, I'm just going to reuse the old copper gasket. People do it all the time. They really do. You put it in. And I don't really have a torque wrench. But I kind of know what 360 inch-pounds feels like. I mean, I've done one before, so I'll just, let's tighten it. So you didn't perform something correctly. No, that's a bad example. Bad example.
I don't want to grease that pulley. It's too hard to get to.
Say, what was that?
I don't want to grease that pulley. It's too hard to get
Oh, perfect. I don't want to grease that pulley. Oh, excellent. The back of my Cessna, most aircraft, all the way in the tail cone, there are these little tiny pulleys, especially on Cessna 150s, that go to the trim. And they always stick. And every year you got to get in there and you got to move them and you got to put a little LPS1 or something on them and get them to roll. I can't fit back in there when I do. The other cables are digging into me and they leave my shirt all dirty. I'm sure they're fine. Right? I'm not going to I'll look at it next year. So what did I do? I've intentionally not performed it. Yeah, that's excellent. Thank you. So what is the answer to that?
Be a decent mechanic.
That's not what I was going to say, but that's the best answer possible. Be a decent mechanic. No! You bring your child and you make them go to the back and do that. That is what my daughter is for. That's why she's in this program, because we can grease those little things. Yes! Okay, so that's intentional. What if I just didn't know? I just didn't know they're back there. There's unintentional. Either way, it didn't happen. So what happens? You have a pulley that freezes. You have a cable that constantly wears over a pulley that's not moving. What happens to the cable eventually? Snaps.
Could you put in access panel back there?
No, you can't just start digging access panels in an aircraft with metal skin. If it's fabric, sure. Yeah. No, you just got to climb back there. Yeah. Okay. So omission. You didn't do it. Commission. Commission is basically where I was going a minute ago. See, commission, accomplishing a task incorrectly. And that's unintentional or intentional. And really, I could think of a million things. I hear it every week, every day. People calling me up, hey, Kevin, I need some advice. Say, well, this is how you got to do it. Well, I don't have that stuff. I don't have that tool. I don't want to do that. It's too hard. Well, that's what you're supposed to do. So I was talking a little bit about the spark plug and not putting the gaskets on, because really everybody does that. They honestly do. They reuse they're copper gaskets. They're thick. People reuse them all the time. It's one of my pet peeves because they're so cheap. It's like, well, why would I throw my license away on a part that costs 12 cents? I'm not. So I've had, is that what they cost now?
75 cents.
Okay, I buy them in a box of hundreds. 75 cents. So 75 cents. And it's a big thing, and it's just one of my pet peeves. In aviation, people take spark plugs out, and it has a gasket. It's called a gasket for a reason. You throw them away. You put a new one on. You put it on. A lot of mechanics say,
Flip it over.
yeah, flip it over. Flip it over. Actually, there's a right side and wrong side, so you can't. They say anneal it. Annealing is a process where you heat it up and quench it. It restores it really does. It restores the plasticity, I think is the word I want, to the metal. Okay, there's nowhere in aviation does it say you can do that. So if it doesn't say that, you can't. Anyway, so people do stuff like this. Spark plug comes out, you lose a cylinder. If you lose one cylinder out of a 4-cylinder engine, you've only got 75% power left at best. So that's not good. So there you go, commission. I just didn't do it. I did it incorrectly because I didn't want to. And believe me, aviation is full of I don't want tos. There are some times when a maintenance manual will call for a specific tool or procedure, and you're looking at, I don't have that. Perfect example is when you guys get into electricity, you're going to do magnetos. Magneto's a thing that makes the spark to the spark plug. And in order to test the capacitor, a little tiny part, and they're very cheap. It says you must test the capacitor with a part number, this particular machine, this particular part number, that's what you use. It does not say or equivalent, it says that. You must use that. All right, so I want to buy that machine. I look it up. Not only is it not available anywhere, but the ones I could find were thousands of dollars. So what are you going to do? Well, I've got this other machine that does the same thing. It really does. And before the new manual was written, the old manual didn't call it out, that part number, and you could use this machine. Now, the new manual says to use this machine, but the old manual says this one's fine. So this one's been fine for the last 35, 40 years. The new manual says to use this one. What do I want to do?
Take a promo. Send it out.
You're the mechanic. Where are you going to send it to?
Well,
You're the magneto shop.
Well, you're gonna have to get that, if it was good 35 years ago and then they changed it,
Uh-huh.
that means that 35 years ago wasn't good enough.
Good point. Something happened. Somebody figured out there's a problem. Somebody figured out it would be good enough. Maybe somebody just greased somebody's palms who wrote the manual to sell his buddy's machine. I don't know.
Yeah, that could be.
It's not up to me to decide. So what are you going to do? You're either now you're at a crossroad. This is a real thing. You're at a crossroad. You have to make the decision. Do I continue to do what I've been doing, knowing that it's not right? Or do I go to the boss and say, or maybe you are, boss, I can't do these anymore because we don't have the right machine. Now, a really smart boss would say, this machine you want to buy, how much is it? Oh, boss, it's about $3,000. And how much does the part cost that you're testing? Oh, the capacitor? They're about $25 each. Okay, start throwing away the capacitor, putting new ones in all your magnetos and charging the customer.
Yeah.
That's what I do.
Yeah.
If it was my own plane, that's what I would do. It's like, it's a wearable part anyway. It's, they don't last forever. It's not, you're not hurting it. You're not screwing anybody. I think you're screwing somebody if you do it the old way and don't do it right. Or tell your customer, hey, very, very rare and expensive machine. We put in a new capacitor for you. If you have a problem with that, then maybe we're not the company for you. I don't know. All right. So, and then extraneous. Extraneous, which is performing a task incorrectly. No, I mean a task not authorized. A task not authorized. And of course, that's unintentional or intentional. First of all, how could I possibly perform a task that's not authorized on accident? Well, as you're going to see, it's more common than not. And it's one of my favorite dirty dozen. It's called the norms. It's the last one we'll talk about now. And that's where it becomes what we call tribal knowledge. It's the way everybody else did it. I'm going to catch you guys left and right. Every time you screw up in my class, I'm going to ask you which one of the dirty dozen did you violate. And you're going to tell me. You're going to be, but it's how we learn, right? When you go out and work in shops, what happens is this is the way we do it. All right. I'll give you an example. So I worked in a fabric shop. I rebuilt fabric airplanes for a while, and so you have a skeleton of a wing, and you would take fabric and you'd lay the fabric. It's like a polyester, and you'd lay the fabric over the wing, and it would be glued on. And on the front, it would be glued like that. It had a 4-inch overlap. And there was two ways to do it. One, you could do this glued seam like that. When you did the glued seam, it was very smooth on the leading edge, and it looked beautiful. The other way is called a sock method. It's literally a sock, and you pull it all the way over, and it's got a sewed seam. So it's got this seam that's been sewed around the front, but it's got a big bump on it. And when you put this fabric on, you actually use an iron to tighten it up. And no matter how hard you try, if it's got a sewed seam, you can always see that seam doesn't run perfectly straight down the leading edge. When you sight down the whole leading edge, you see it, and it doesn't look nice. So the glue would always look way better. So if you're doing a show plane, you really want that glued on there. Well, the company that made this product, they made like this thin little blanket that you could put underneath this fabric to take out any imperfections in the skin. So it was this nice, soft looking, beautiful thing. And what was happening is, literally, the shop I was working for, because everybody was doing it, was putting this padding on and then gluing the fabric on top of the padding. Well, there was a case where the glue came loose from that padding, it tore out, and the wing lost all of its skin, wrapped around the aileron, and killed everybody. But we didn't know that. It's the way they were doing it. And that was one of the things where it said, hey, Kevin, tomorrow we're going to ask you to go into, and I want you to recover those wings. Oh, recover the wings. I'm going to take the book home and read it. Gigantic letters. Do not ever glue this stuff on top of the padding. Bold, giant, black. Come into work. Hey, we can't do this. It's wrong. Oh, that's what I've always done. Okay, well, let's just make it right. Somebody's going to get hurt. This is for this method. So, up to that point, they're performing an extraneous task, not authorized, unintentional. Nobody knew it was bad. Now at that point after, if we did it, oh, that's intentional. So, now the funny thing about that is, once we brought it to everybody's attention, we stopped doing it immediately, but we started watching for it and all the aircraft that were coming to us that we didn't build, and you'd be surprised how many of them were that bad. And so we'd actually have to rip them open, pull the padding out, and resew it and paint it. It was crazy how many people were doing this. So, all right. All right, so credit where credit is due. Our neighbors to the north, America's Hat, Transport Canada, and this was DuPont. I don't have it in my notes. I just know it was DuPont, so I give credit. Conducted a study throughout. So I'll try and write a little bit nicer. Throughout the early.
Does that say DuPont?
Yeah, DuPont.
DuPont.
The guy. That was the guy. I forget his first name. I think it was Tom. Throughout the early 1980s. Oh, 1990s. It was late 80s, early 90s. To determine. Early 90s. Early 1990s. It was late 80s to early 90s. We'll just say throughout the early 90s. To determine the cause of human error. To determine the cause of human error. That led to aircraft accidents. That led to aircraft accidents. And I talked about this earlier. And what happened is he identified 12 causes. They identified 12 causes. And then the FAA picked it up and they gave it a cool name. I think the FAA gave it the name. I'll give them credit. 12 causes that the FAA, and don't say FFA, that's a different organization, now refers to as the Dirty Dozen. All right, then as we do every night, at this time we take a break.